Facts about matrices. Basic concepts. 1. A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. 2. The numbers in a matrix are called elements or entries. 3. The size of a matrix is determined by its number of rows and columns, often denoted as m times n. 4. A matrix with an equal number of rows and columns is called a square matrix. 5. A matrix with only one row is called a row vector, and a matrix with only one column is called a column vector. Operations. 6. Matrices can be added, subtracted, and multiplied. 7. Matrix addition and subtraction require the matrices to have the same dimensions. 8. Matrix multiplication is defined only when the number of columns in the first matrix equals the number of rows in the second matrix. 9. The identity matrix is a square matrix with ones on the diagonal and zeros elsewhere. 10. The inverse of a square matrix, if it exists, is another square matrix that, when multiplied by the original, results in the identity matrix. Special matrices. 11. A diagonal matrix has all elements outside the main diagonal equal to 0. 12. A triangular matrix has all elements above or below the main diagonal equal to 0. 13. A symmetric matrix is equal to its transpose. 14. An antisymmetric matrix is the negative of its transpose. 15. An orthogonal matrix has its transpose equal to its inverse. Applications. 16. Matrices are used in various fields, including physics, engineering, computer graphics, and economics. 17. They are used to represent systems of linear equations. 18. In computer graphics, matrices are used for transformations like rotations, scaling, and translations. 19. In physics, matrices are used to represent quantum states and operations. 20. In economics, matrices are used to analyze input-output models. Properties. 21. The determinant of a square matrix is a scalar value associated with the matrix. 22. The determinant of the product of two matrices is the product of their determinants. 23. The inverse of a matrix exists if and only if its determinant is non-zero. 24. The rank of a matrix is the maximum number of linearly independent rows or columns. 25. The eigenvalues of a square matrix are the values lambda that satisfy the equation x equals lambda x, where x is a non-zero vector. Advanced topics. 26. Eigenvectors are the corresponding non-zero vectors x in the eigenvalue equation. 27. The diagonalization of a matrix involves expressing it as the product of a diagonal matrix and two invertible matrices. 28. Singular value decomposition, SVD, is a factorization of a matrix into the product of three matrices. 29. The trace of a square matrix is the sum of its diagonal elements. 30. The norm of a matrix is a measure of its size or magnitude. Historical facts. 31. The concept of matrices originated in ancient China. 32. The term, matrix, was introduced by James Joseph Sylvester in the 19th century. 33. Arthur Cayley developed the algebra of matrices. 34. Matrices played a crucial role in the development of quantum mechanics. 35. Matrices have been used in cryptography for centuries. Fun facts. 36. The Matrix in the movie, The Matrix, is a fictional computer system. 37. Matrices are used in image processing to apply filters and effects. 38. There is a field of mathematics called linear algebra that deals exclusively with matrices. 39. Matrices can be used to solve puzzles like Sudoku. 40. There is a special type of matrix called a magic square, where the sum of each row, column, and diagonal is the same. Additional facts, 41 to 100. Please let me know if you would like me to continue. Additional facts, 41 to 100. Matrix calculus. 41. Matrix calculus is the extension of calculus to matrices. 42. The derivative of a matrix with respect to a scalar is a matrix of the same size. 43. The derivative of a matrix with respect to a vector is a matrix of the same size. 44. The chain rule for matrices is similar to the chain rule for scalar functions. 45. Matrix calculus is used in various fields, including machine learning and optimization. Block matrices. 46. Block matrices are matrices partitioned into smaller submatrices, called blocks. 47. Block matrices are often used to represent large matrices or matrices with specific structures. 48. Operations on block matrices can be performed using the corresponding operations on the submatrices. 49. Block diagonal matrices are matrices where all non-diagonal blocks are zero. 50. Block triangular matrices are matrices where all elements above or below a diagonal block are zero. Applications in various fields. 51. Matrices are used in computer vision for tasks like image recognition and object tracking. 52. In control theory, matrices are used to represent systems and design controllers. 53. In statistics, matrices are used for data analysis and modeling. 54. Matrices are used in graph theory to represent graphs and analyze their properties. 55. Matrices are used in game theory to model strategic interactions between players. Special types of matrices. 56. A Toeplitz matrix has constant diagonals. 57. A Hankel matrix has constant anti-diagonals. 58. A Vandermonde matrix is a special type of matrix with elements arranged in a geometric progression. 59. A Hilbert matrix is a matrix with elements given by the reciprocal of integers. 60. A Pascal matrix is a matrix whose elements are given by binomial coefficients. Matrix decomposition. 61. QR decomposition decomposes a matrix into the product of an orthogonal matrix and an upper triangular matrix. 62. Cholesky decomposition decomposes a symmetric positive definite matrix into the product of a lower triangular matrix and its transpose. 63. Liu decomposition decomposes a matrix into the product of a lower triangular matrix and an upper triangular matrix. 64. Schur decomposition decomposes a matrix into the product of an orthogonal matrix, an upper triangular matrix, and its transpose. 65. Jordan canonical form is a diagonalization of a matrix over the complex numbers. Matrix properties. 66. The trace of a matrix is additive, meaning the trace of the sum of two matrices is the sum of their traces. 67. The determinant of a matrix is multiplicative, meaning the determinant of the product of two matrices is the product of their determinants. 68. The rank of a matrix is the maximum number of linearly independent rows or columns. 69. The null space of a matrix is the set of all vectors that, when multiplied by the matrix, result in the zero vector. 70. The column space of a matrix is the set of all vectors that can be expressed as a linear combination of its columns. Matrix equations. 71. The equation Ax equals B, where A is a matrix, X is a vector, and B is a vector, is called a linear system of equations. 72. Gaussian elimination is a method for solving linear systems of equations. 73. Cramer's rule is another method for solving linear systems of equations, using determinants. 74. The least squares method is used to find the best fitting solution to an overdetermined system of linear equations. 75. The pseudo-inverse of a matrix is a generalization of the inverse for non-square matrices. Matrix inequalities. 76. The Frobenius norm of a matrix is a measure of its size. 77. The spectral norm of a matrix is the largest singular value. 78. The trace norm of a matrix is the sum of its singular values. 79. The inequality, Ax, is less than or equal to A, X, holds for any matrix A and vector X. 80. The inequality, AB, is less than or equal to A, B, holds for any matrices A and B. Matrix applications in machine learning. 81. Matrices are used to represent data in machine learning algorithms. 82. Matrices are used in neural networks to represent weights and biases. 83. Matrices are used in support vector machines to represent the decision boundary. 84. Matrices are used in principal component analysis to reduce dimensionality. 85. Matrices are used in clustering algorithms to group similar data points. Matrix applications in cryptography. 86. Matrices are used in public key cryptography to encrypt and decrypt messages. 87. Matrices are used in hash functions to generate unique digital fingerprints. 88. Matrices are used in digital signatures to verify the authenticity of messages. 89. Matrices are used in quantum cryptography to provide secure communication. 90. Matrices are used in steganography to hide information within other data. Miscellaneous facts. 91. The Kronecker product of two matrices is a larger matrix formed by multiplying each element of the first matrix by the second matrix. 92. The Hadamard product of two matrices is a matrix formed by multiplying corresponding elements of the two matrices. 93. The Moore-Penrose pseudo-inverse of a matrix is a unique matrix that satisfies certain properties. 94. The Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. 95. The Sherman-Morrison formula provides a way to update the inverse of a matrix after a rank 1 modification. Historical facts. 96. The concept of matrices originated in ancient China, with the 9 chapters of the mathematical art. 97. The term, matrix, was introduced by James Joseph Sylvester in 1855. 98. Arthur Cayley developed the algebra of matrices in the 19th century. 99. Matrices played a crucial role in the development of quantum mechanics. 100. Matrices are used in various fields, including physics, engineering, computer science, and mathematics.